Welcome to Mechanics 1. Today's learning outcome is analyzing multi-component systems. When analyzing multi-component systems, we need to follow the 5-step approach. Think about the problem, try to understand the problem, describe the problem mathematically, solve the equilibrium equations, and learn from the solution. Problem statement. The tower crane is used to hoist a 2 megaton load upwards at a constant velocity. The 1.5 BD and 0.5 megagram jib BC have centroids of mass at G1 and G2 respectively. Determine the required mass of the counterweight C so that the resultant moment produced by the load and the weight of the tower, crane, jib about point A is 0. The center of mass from the counterweight is located at G3. Let's think about the problem and try to understand the problem. We can make note about the center of masses at G1 and G2 and the location of the counterweight C. We should also make a note of point A and the weight that we're lifting. Let's try to simplify this diagram by drawing a free body diagram. The steps for drawing the free body diagram are outlined below. Draw a rough sketch of the structure, identify the reaction forces, identify the applied forces, and note the measurements. As you can see, a simplified diagram is shown here. For the case of simplicity, we've drawn the forces as weights times gravitational acceleration. Describe the problem mathematically and solve the equilibrium equations. Let's recall. We're looking to determine the required mass of the counterweight so that the resultant moment produced by the load and the weight of the tower, crane, jib about point A is 0. The center of mass of the counterweight is located at G3. And we've chosen to write that as MC as the force from this counterweight. Let's start by saying that for a statics problem, the summation of moments has to be equal to 0, and that the summation of moments at point A has to equal to 0. From there, we can start by determining the moment caused by each force and solve for our mass, MC. Our 500 kilogram weight, G2, is located 4 meters away and creates a counterclockwise moment, written as 500 times 9.81 times 4. Our 1500 kilogram and 2000 kilogram forces both cause a clockwise moment with the respective distances of 9.5 and 12.5 meters, both resulting in clockwise moments, therefore shown as negative. We can note that these are all the forces that are on our diagram, and now we just have to solve for MC. Isolating MC, we find it is 4,966.67 kilograms, or 4.97 megagrams.